This is just a brief video to show what I've been doing recently with UI work. I think it's mostly just to prove to myself that I haven't been completely wasting my time, spare time here these last few months. The idea eventually, this is a web-based interface, so it can be accessed from anywhere over the internet. And I'm going to use it for setting up and eventually providing controls for basic robotics and electronics kind of experiments I've been doing. It's based on, the design here is based on Twitter Bootstrap. If you're familiar with that, this is going to look bland. If you're not familiar with it, it should look relatively polished. Key point to me though is that it's very themable, very easily. If you go to wrapbootstrap.com or a few other sites out there, you can see just how diverse the themes are, and they're very easy to apply. It definitely hits all the buzzwords right now. It's responsive. So if I change the width here, as I go narrow, like you eventually would get to an iPad, you can see the menu up top changes on more complex forms and things. It all kind of works itself out, so that the idea is you can use it on different width displays. Get the width back out here. Most of the work I've been doing recently is in the servos. The idea being you set up servo groups. So I have a pan tilt 1 servo group. It has an X servo and a Y servo. I can create a new servo in that group. I can click on a servo to edit the various parameters. All servers have an init or initial pulse. Change that to 1613, hit save. I'll do it again. One of the work I've been doing here is setting up validation. So code is required. You get the nice displays and indicator. A lot of boring stuff, but it takes time to work it out. I've been experimenting, so you can edit the fields in the common pattern there where we click and edit on a form. I've also been experimenting with when it makes sense to use edit in place. So the X server has an initial pulse that we set there. We can also set it in place here. So we'll change to 1615. And we can see that it's changed in the underlying database. The underlying database is an embedded database, so not a lot of setup required, which is nice. Most of the work I've been doing recently is in this calibrate dialog. So when you set up a servo, we need to calibrate the start and the end positions. Servers are controlled by these pulse values, and I need to take those pulse values and equate them to degree values. So in this case, the pulse of 1211 is equivalent to minus 90 degrees in the servo movement. When I'm moving the slider here, if I have the servo turned on and everything configured, it's actually moving the servo as I drag the slider. And so what I'm doing is looking for the endpoints here. One of the interesting things I've set up is that if you're on the endpoint, so I'm trying to calibrate where the start position of the servo should be, when I start changing the values here, I'm actually changing the servo in real time. So as I change this, the servo moves, and it lets me easily find the stop value that I can save at that. Same with the other side, of course. If I'm in the middle though, and I'm changing start values, I don't want to change the current position. What I do want to change is, verifying that my start and end positions end up with the correct logical degree calculation here. I know that's too complex. It's not super usable. It's just one of those things that makes sense for me personally. You can see a little bit of the abstraction that I'm heading towards here in that you select a controller device. Right now, the only thing I have configured up is a Pololo Mini Master servo controller, but eventually you'll be able to select my custom microcontroller here, um, and then I abstracted I/O connections here. So right now it's connected to the COM port 21 via the Java Simple Serial library, but you could also connect via RxTX, which I would never do, I don't think. More interesting probably is the network serial proxy I've been working on. So the idea there is that it's a native C++ application I've written that connects to the serial port, but it proxies over a network. There's commercial solutions out there too. But what that lets you do, I've already mentioned that you have the web interface here that can be accessed from anywhere on the internet, but underlying the server has to connect to the microcontroller via some kind of wired connection. By using the network proxy like that though, the serial connection itself can actually be over the network, or over a network. So I guess the better way to understand it, one of the demos I'm hoping to present here eventually is that I can take the servo software, installing it on a BeagleBone Black, for example, which is a $45 mini computer. I can install the server or the serial proxy there. that will be connected to the webcam and the servos and things. And imagine it could be connected to a cellular modem or a Wi-Fi hotspot, provided by a cell phone. If you have that, you have a really inexpensive device that can be installed anywhere you have cellular coverage. You can have complete control from anywhere over the internet. The servo and control UI could be running somewhere else. Uh, That'll make more sense later, I think. So I think that's about it. The system here, what I'm heading towards, here's I/O connections. So this is where you create your I/O connections. Java serial port, blah, blah, blah. Uh, what I'm heading towards there right now is this video camera pan tilt demo. The idea being you can come here and this is going to be controlling the pan tilt device here where you're looking at, and you'll get a live HD stream here. Doing live HD video is actually it's fairly difficult. You'd think it would be easy by now, but it's just not if you don't want to have any kind of latency, particularly for iOS devices. In fact, I don't really have a good solution for that yet, but I have some interesting ideas I want to try. But that's where I'm headed. I think that's enough for now. I'll have a complete write-up and a better presentation here later on.